Can quantum mechanics be complete? Look up at the night sky. What do you see? Pinpricks of light, vast emptiness, a cosmic clockwork ticking with silent, predictable grandeur. For centuries, that's what we believed our universe was, a giant, beautiful machine. If we knew the position and velocity of every particle, we could, in theory, rewind the tape of time to the very beginning or fast forward to the very end. It was a universe of certainty. But then, in the early 20th century, we peeked behind the curtain. We delved into the realm of the impossibly small, the world of atoms and particles, and the solid, predictable universe vanished. In its place, we found a realm so bizarre, so utterly mind-bending, that it feels less like science and more like the most potent magic. We found quantum mechanics, and ever since, one haunting question has whispered in the minds of every physicist, every philosopher, every seeker of truth. Is this strange, magical theory complete? Does it tell us the whole story of reality? Or are we, as the great Albert Einstein feared, merely seeing the shadows on the cave wall, missing the true, majestic source of the light? Today, we are going on a journey not just through space, but through the very nature of existence itself. We are going to ask if quantum mechanics can be complete, and in doing so, we might just discover that the answer is more incredible than anything we could have imagined. Let's start with the magic. And the first, and perhaps most profound piece of magic, is something called superposition. Imagine a single electron. Now, where is it? Our common sense says, well, it must be somewhere. But the quantum world laughs at our common sense. Until we look, until we measure it, that electron isn't in one place. It exists in a ghostly dance of all possible places at once. It is a shimmering cloud of potential, a maybe here and a maybe there existing simultaneously. It's not that we don't know where it is, it's that it genuinely has no single defined location. Think of it like a cosmic coin spinning in the dark. Is it heads? Is it tails? The answer is, it is both and it is neither. It is in a state of pure potential. It is only when we reach out and catch it, when we observe it, that it decides, in that very instant, to become heads or tails. The act of looking, of conscious observation, seems to force the universe to make a choice. This leads us directly to the second piece of sorcery, the observer effect. This isn't just about looking with your eyes. It's about the fundamental act of measurement. How does a particle know it's being watched? It's as if the universe is a vast, interconnected mind, and reality remains in a dreamlike state of possibilities until a consciousness, a witness, appears. Then, and only then, does the dream collapse into the solid world we experience. This was deeply unsettling to Einstein. He famously argued, God does not play dice with the universe. He refused to believe that reality was fundamentally probabilistic and random, that it relied on an observer to snap it into focus. He believed there must be a deeper, hidden reality, a set of hidden variables that determined the electron's path from the start. He believed quantum mechanics was, by its very nature, incomplete. It was a statistical approximation of a truer, more deterministic world beneath. But then, the quantum magicians had another trick up their sleeve, one that would make the idea of a hidden, local reality almost impossible to maintain. A trick so spooky that even Einstein called it, well, spooky action at a distance. This is the magic of quantum entanglement. Imagine you create two particles together, like twins born from the same quantum event. They are intimately linked, entangled. Now you take one of these particles and you fly it to the farthest edge of the galaxy. You leave its twin here with you. Now you perform a measurement on your local particle. You force it to choose a property, let's say Its spin. It collapses from a cloud of up and down into a definite up. And in that exact same instant, its twin, billions of light years away, instantaneously collapses into the opposite spin, down. They communicated faster than light. In fact, they communicated with infinite speed. How? Information didn't travel between them. It's as if they are not two separate entities, but two parts of a single, deeper whole. They are connected by an invisible thread that transcends space and time. It's as if the universe, at its fundamental level, is non-local. Distance is an illusion. Separation is a myth. This was the crux of the debate. Einstein arguing for a sane, local, hidden reality. The quantum pioneers like Bohr arguing that, no, the universe is just this strange, and what we call reality is created at the moment of observation. For decades, this was philosophy. Beautiful, mind-bending philosophy. But then, a brilliant physicist named John Bell devised a way to test it, a way to ask the universe a direct question. Are there hidden variables, or is spooky action real? And the universe answered. Experiment after experiment, with ever-increasing precision, has confirmed it. There are no local hidden variables. Entanglement is real. The spooky action is a fundamental feature of our cosmos. Einstein, in his desire for a comfortable universe, seemed to be wrong. So, case closed, right? Quantum mechanics is complete. It has passed every test. It predicts outcomes with stunning accuracy. Our phones, our computers, the very device you're watching this on, are built upon the reliability of quantum laws. It works. But does it feel complete? Let's sit with the implications. If quantum mechanics is the complete picture, then what is it telling us? It tells us that at the bedrock of existence, there are no solid things. There are only waves of probability, potentialities. That the solid chair you're sitting on is a magnificent illusion, a consensus reality formed by trillions of quantum collapses happening every moment. It tells us that the observer is not separate from the system. The seer and the seen are linked in a cosmic dance. Consciousness is not a passive ghost in the machine. It may be an active participant in shaping the very reality it perceives. We are not just in the universe. The universe, in some profound way, comes into being through us. And it tells us that the universe is fundamentally interconnected in a way that defies our classical understanding of space. Entanglement suggests a level of unity, a cosmic oneness that echoes the oldest mystical and spiritual traditions. The Hindus call it Brahman. The Buddhists call it Indra's net. And now, physicists, through cold, hard math and experiment, are pointing to what seems to be the very same truth, that all is one. This is where the magic becomes mystical. This is where science touches the ineffable. But the story doesn't end there, because the quest for completeness has led to some of the most breathtaking and futuristic ideas in all of human thought. One of them is the many worlds interpretation. What if, when that quantum coin spins, it doesn't choose heads or tails? What if, instead, the universe splits? In one branch of reality, you see heads. In another, equally real branch, a version of you sees tails. Every quantum decision, every possibility is actualized in a near infinite tapestry of parallel universes. There's a world where you took that job overseas. A world where the dinosaurs never went extinct. A world where everything is the same, except the coffee you drank this morning was slightly hotter. In this view, quantum mechanics is complete. There is no collapse. The wave function never breaks. It just endlessly branches. And we, as conscious beings, are only aware of a single thread in this unimaginably vast, multiversal tapestry. It's a dizzying, glorious, and humbling idea. Another, perhaps even more radical idea is the holographic principle. This suggests that our seemingly three-dimensional reality, you, me, the stars, the galaxies, is actually a projection, a hologram. And the information that creates this magnificent illusion is encoded on a distant, two-dimensional surface that surrounds us, like the event horizon of a black hole or the very boundary of the universe. Think of it like a cosmic credit card. The 3D movie you experience is just a projection from the 2D magnetic strip. In this view, quantum mechanics and gravity find a strange union. The fuzziness of quantum particles, their probabilistic nature, might simply be a consequence of the fact that we are seeing a low-resolution projection of a higher dimensional truth. Reality is pixelated, and the quantum is the grain of the cosmic film. So, can quantum mechanics be complete? If by complete, we mean a perfect set of rules for predicting outcomes in experiments, then yes, it is arguably the most successful and complete scientific theory ever devised. But if by complete, we mean a theory that gives us an intuitive, comfortable story of what is really happening, then perhaps not. Or perhaps the true story is so alien to our everyday experience that it feels like magic. It points to a reality that is mental, interconnected, and participatory. A reality where consciousness and cosmos are co-creators. The magic of the quantum world is not a bug in the system. It is the system. It is the fundamental software of existence. We are just beginning to learn how to read the code. And this is just the beginning of the conversation. The journey into understanding the nature of reality is the greatest adventure we can ever undertake. If this journey into the quantum maze sparked your curiosity, if it made you look at the world in a slightly different, more magical way, then do me a favor. Give this video a thumbs up and subscribe to the channel so you don't miss our next dive into the mysteries of the cosmos. The conversation is just getting started, and I want you to be a part of it, so leave a comment below. Tell me what you think. Do you believe quantum mechanics is complete? Or do you feel, in your bones, that there's an even deeper layer of reality waiting to be discovered? And if you are truly hungry for more, if you want to explore the edges where physics meets mysticism, where the holographic principle meets the nature of consciousness, then I invite you to check out my book, Holographic Multiverse. In it, we go even deeper down the rabbit hole, exploring how all these breathtaking ideas weave together to form a new picture of who we are and what this universe might truly be. The link is in the description below. Thank you for watching, for wondering, and for being a part of this incredible quest. Remember, the universe is far stranger and far more wonderful than we have been led to believe. Never stop exploring.